So we're going to finish 9.3, section 2. Tomorrow in class, you're going to work on the test review. The solutions are posted. So come on Friday and say, hey, Mrs. Meadows, I didn't understand this. Can you go over this? I will find the video of, I don't know, somebody working this out, and I'll post it so you guys can watch it over the weekend. I'll actually try and post it before then. I'll put it maybe in the assignment tomorrow so you can watch it as well, like when you get home, but just to prepare yourself. But Friday we will go over stuff, and then Monday is our test, yes? Yeah? Okay. Okay, this is all we got to do. This is it. 11, 12, 13, 14, and then we're finito with conics, which is good. We're going to go into, the next stuff is not bad, the next two sections, quick little quiz on it, and then we're talking about polar coordinates and graphs. It sounds scary, but it's really not. It's not, I promise. All right, so let's talk about what we have here. If I have vertices at plus minus 10, as soon as I see the word vertices, what letter do I think of? Good, A. A tells us our vertices, the distance from the center to our vertices. So we're at plus and minus what? So over here at positive 10, over here at negative 10. What does that tell me? Two really important pieces of information. Where is my center? And what did you just say, Eva? It's horizontal. Awesome. All right. Along with horizontal, I know that I'm going to have x squared over what? A squared. Perfect. Y squared over B squared equals 1. I can tell, those of you who actually looked at your homework yesterday, you went over this, it starts to click. All right. What else do we know? Do we? Okay, well, think about this. What is the equation of my asymptote? They gave me plus minus 5x. What do I know, ladies and gents? What do I know my horizontal asymptote is? Tell me again. B over A. Okay, so what can I set equal to each other? 5 over 1 equals what? What? 5 over 1 equals B over A. Okay, hold on a second. Does B just equal 5? No. Wait a second, guys. Hold on. I want you to pay attention to this. I know the last example we did, it was 4 over 1, right? And you're like, oh, B is 4, A is 1. Why was A just 1 in that case? Because at the beginning, what was our value of A? 1. What's our value of A, guys? A equals 10. So do you have a number to plug in for A? So it's 5 over 1 equals B over 10. Ooh, so now we cross multiply. So B equals what? 50. Perfect. What do I need in order to write my equation? I need my center, which I have, and I need my A and my B, yeah? Do we have what we need? X squared over 100 minus Y squared over. Okay, first of all, before you go, I don't know. Oh my God, what is 5 squared? Okay, so 25, and then how many zeros do I put on that? I put 2. There you go. Woo! The hardest calculations you got to do right there. But that's it. You guys will always be able to figure out, always, with the information given, you'll always be able to figure it out. Good job, though. Very good job. All right, let's look at the next one. Vertices. What letter? Okay, I think of A when I see vertices. So, where are my vertices? I love it. They're on the Y. That is perfect. So they're on the Y. So what do I know about my lovely hyperbola? It's a vertical, so I'm going to go ahead and write down the equation. Y squared over A squared minus X squared over B squared equals 1. Now, just by drawing a picture, I know where is my center. It's at 0, 0 because it's equidistant from the vertices. So I have now discovered my A value. Plus minus what? 5. All right, so let's survey the information that they gave us. All we did was just kind of write down the puzzle pieces, everything that they told us so far. Did they give me the equations of the asymptote so I can say A over B, B over A? No. If they did, what would I plug in for the a value? If it was y equals a over b or b over a, what would I plug in for the a? 5. Okay, good. Just make sure you see that. What did they give me? That's going to be helpful. They gave me a point. They gave me a point that this hyperbola passes through. So they gave me an x value and they gave me a y value. What should I do with those numbers? Plug them in. Guys, I write the x and the y above just so you don't make a mistake. So easily, some of you will put the 3 where y squared should be. Is that the right place to put it? No, it should be 10 squared over what? 5 squared. That does not just simplify to 2. Equal, or minus, my bad, 3 squared over b squared equals 1. We did a problem just like this yesterday. So I have 100 over 25 minus 9 over b squared equals 1. Couple things you could do here.
Simplify that.
We could simplify that. We can't cross multiply yet because we don't have both fractions alone. But what can I simplify 100 over 25 to? 4 over 1. Okay. Do you have to do it at that point? No. Just make your numbers a little smaller. If you see it, great.
Is that just like work out one time, or does it work out with everything? Like 10 divided by 5 is 2 and 2 squared?
It's because it doesn't always happen that way. Yeah. Just don't get in the habit of being like, oh, yeah, don't do that. It happens. It did happen there, but just be careful. All right, so now what do I do? Okay, I'm going to subtract 4. So negative 9 over b squared equals what? Negative 3 over 1, okay. How do we solve this? You cross multiply, so I have negative 3b squared equals negative 9. Now what? Divide by negative 3. So b squared equals what? 3. Do I need to go ahead and say, okay, well, b is going to be plus or minus root 3? No, because the only thing I need to write my equation is my a value squared and my b value squared. Do I have both of those things now? Yes, so I'm going to say y squared over what? 25 minus x squared over 3 equals 1. It's okay. You don't have to apologize. No worries. You guys are super. Yep. Yep. Now, if you did not change 100 over 25 into 4, it's no big deal. You would have subtracted, right? You would have said 100 over 25. We would have moved it to the other side. Right? What is 1 if I was going to write it as 25ths? It'd be 25 over 25, right? So 25 minus 100 would give me negative 75 over 25, which equals negative 3, which is what we got, same thing. You'll get the same answer. You just got to, math skills. Ooh, foci. As soon as I see that word foci, what do I think? C. Okay, good. Good. That's helpful. That's helpful information. So where are my foci? On what axis? On the x. Good. I'm going to put 1 over here at negative 3 square root of 5, 0, and over here at positive 3 square root of 5. Does it have to be exactly perfect? No. You just need to know the general area. So what did that tell me? 2 really important things. It's horizontal. Good. And the center. Where's my center? At 0, 0. Perfect. So horizontal means I'm going to have x squared over a squared minus y squared over b squared equals 1, yeah? Okay. What other piece of information did they give me? So y equals plus minus 2 over 1 times x, correct? Okay. What's the equation? Y equals which one? B over a? Okay, so plus minus b over a. So what can I set equal to each other? 2 over 1 equals b over a. Now, we need to be careful here. In all of the examples we've done so far, we have been given an a or a b value. So we could just say, hey, this works. Do we know the a or the b value? So we can't just assume that b equals 2 and a equals 1. Because that could be, it could have been like 10 over 5. Your b value is 10 and your a value is 5. And then it did what? It simplified. So if you don't have either one, right? We don't have anything to I didn't mean to do that. We don't have anything to substitute in. We just need to solve this. Now you guys will be fine. Just relax. There was something on WebAssign like this. But what do I do here? How do I solve this? I'm going to cross multiply, okay? So b equals what? 2a, okay? How is that helpful? I know what c equals, don't I? Plus minus 3 root 5. Okay, Logan's saying, well, wait, what about the Pythagorean theorem? Okay, so let's write the Pythagorean theorem. What can I do here, guys? Can I take this and put it in there? Yes, you guys had one of these on WebAssign for your ellipses. It's the same concept. What is your c? My c is 3 square root of 5, and I have to do what with it? Square it. Equals, equals what? A squared plus what? Do you see how I wrote it? The reason we can't just say that b is 2 and a is 1 is because you don't know either one. You don't know that. You're not for sure. The simplified fraction there is 2 over 1, but it could be different. So what happens when we do this? Well, this 2 goes here and here, right? So 3 squared is times what? Square root of 25, which is 5. Good. Then I have here a squared plus what? 4a squared. Very good. So 45 equals, now what? A squared equals 9. Yeah? So what does a equal? Plus or minus 3. All right, I need a squared, which I have, to write my equation, and I need b squared. There's a couple ways I could find b squared. Can I use the Pythagorean theorem again? Yes. Or I could do what with this? I could plug it in, couldn't I? If I do that, if I plug in 3, what is b squared? What's 3 times 2? 6. So what's b squared? If b equals 6, what's b squared? 36. Now, some of you might want to just put it back into the Pythagorean theorem. You can do that as well. You could go over here and say, okay, I had 45 equals, what was my a squared? 9 plus b squared. Then you would subtract from both sides. You get 36 equals b squared. Same thing. But now do you have what you need? Yeah. So we had it was horizontal, right? So x squared over 9 minus y squared over 36 equals 1. Just be careful. When they give you the asymptote, a lot of the times, they'll give you the equation of the asymptote, and they'll also give you the a or the b. So you can just make that assumption. But every once in a while, they'll give you the c value, and then, oh, man, I got to figure out the other one. Just be careful. Just be careful. All right, let's do the last one, and then we're done. How is this one a little different? All right, so 5, 1, 2, 3, 4, 5, negative 2. And then I have 1, negative 2. Yeah? When I think of A, I think of vertices. When I think of vertices, I think of A. Now, you can figure out the center 3 different ways. 1, you can look at your graph and count. 2, I showed you guys algebraically. You can say 5, negative 2, and then 1, negative 2, right? Which value is changing? The x, right? So the middle of this would be 5 plus 1 is 6, divided by 2 is, so your center would be at 3, negative 2. So over 3, down 2.
Where'd you get the 2 from?
It's just going to stay. The negative 2?
No, like when you did the 5 plus 1.
Because you're finding the middle. 5 plus 1 is 6, right?
Yeah.
And 6 divided by 2. Because the center's in the middle, isn't it, of the two vertices?
Oh,
So you're just finding the middle. Where's another way you could have seen where the center was? In the equation of the asymptote, right? That's why it's important. I'm going to give you those formulas, but you need to know which one is vertical and which one is horizontal. But think about it. The h part goes with the x value, correct? Do you see this? And then the k is the other one. So your center is at 3, -2. Any way you wanted to look at that, that's fine. But we know a lot of things. We know that we have what kind of a hyperbola? I have a horizontal. Okay, so I know it's horizontal. I know my equation is going to be x minus h squared over a squared minus y minus k squared over b squared. Why am I using that h and k thing? Because the center's not at 0, 0. So look, here's your h, here's your k. Good, very good. Now we got to find our a and our b. Well, we can do that, guys. They told us the distance, the vertices. How far is it from one of my vertices, so 5, -2, to my center of 3, -2? What's the value? How far is it? 2. So A is plus or minus 2. Perfect. Why? Talk to me.
Because that's where it's moving forward.
Right, look, you're going 2 to the right or 2 to the left, correct?
Okay, that's fine.
Okay, just want to make sure you see it. So now we got to find the B. So did they give me a piece of information that will help me?
Yes.
The asymptote. Guys, don't worry about the minus, the 3. It did. All that is telling you the center. This is what you need to focus on. We have a horizontal. What is the equation of a horizontal? Is it plus minus A over B or plus minus B over A? Excuse me. B over A. All right, so what is my B? Do I know? Okay, 3. I meant to do it like that. How do I know for sure the B is 3? Because we already know what the A is. Does that make sense?
Yeah.
We remember the last example, we had C, so we didn't know what A and B were, but if you know one of them, then this makes your life really easy. So if A is plus minus 2, B is plus or minus 3. Can you write your equation now? Yep. So it's x minus, what's your h value of your center? 3 squared over a squared is 4. Yeah?
Sorry, I kind of missed how you got.
Okay, so the equation of an asymptote.
But, like, what are those other, like, numbers?
Okay, well, the equation of the asymptote is 3 over 2, correct?
Yeah.
Okay, so 3 over 2, that's our B over A or A over B. So then you look at your little sheet or whatever, wherever you're writing it, the equation of the asymptote. If you have a horizontal asymptote, is the slope in front of your equation here, is it B over A or is it A over B?
B over A.
It's B over A. Now, we have already determined that our A value was 2, because that's the distance from the center to the vertices, right? A is 2. So what is this equation telling you that B is? B is 3.
So we just ignore the other one?
Ignore what other one?
-2, x minus
That's the center.
Oh.
That's telling you the center. That's telling you that you're not at 0, 0.
Okay.
So if we finish writing our equation, that's okay. You have x minus 3 squared over 4 minus, what does this look like? Y what? Y plus 2. Logan, good job. Why is it plus? Thanks, babe. And then what's your b squared? B squared. 9. Not times 2. And then that's it. So the rest of your WebAssign, guys, is going to be a tiny bit more difficult. The only thing that changes when you are not at the origin is you have to count a little bit. I think algebraically, writing the points on top of each other, seeing which values change, which stay the same, that is... All right, say you have something like this. Your two vertices are -5, 3, and positive 3. Make them both 3. Just pretend that's what it is. -5, 3, and positive 3. So you're trying to figure out how far it is. If you don't draw the picture, you could very easily get this wrong. A lot of people yesterday were like, okay, -5 and 3, it's -2. Guys, is it negative 2 spaces from here all the way over here? No. If you draw the picture, you would see it. But if you put them on top of each other, and first of all, notice which ones change, the x, right? If you're moving from negative to positive, think about that. We're going 3 spaces to 0, then 5 additional spaces. What is the net change? How much did it change? 8. So 8 divided by 2 would be 4. Same thing, if you're going here from negative 5, how many spaces does it take to get to 0? 5. Then you have 3 more, so it's a total of 8. Whenever there's a negative and a positive value, we sometimes get that. Remember, the net change, how much you moved, is absolute value. You're not just subtracting. You have to make sure you understand it's 5 spaces away on the negative, then 3 more on the positive. Does that make sense? All right, so make sure you guys see that.